Two particles A and B have masses 2m and 3m respectively. They are moving towards each other in opposite directions along the same straight line on a smooth horizontal plane when they collide directly. Immediately before they collide, the speed of A is 3u and the speed of B is u. As a result of the collision, the speed of A is halved and the direction of motion of each particle is reversed. Our questions are: find the speed of B immediately after the collision and find the magnitude of the impulse exerted on A by B in the collision. This is our figure. This is particle A, mass is 2m. This is particle B, mass is 3m. This is before the collision, that is initial velocity of A, 3u. Then this is the initial velocity of B, u. Then this is final velocity of A, 3u by 2, and we need to find out the final velocity of B after the collision or immediately after the collision. Now we can use the conservation of momentum equation. Conservation of momentum equation. Then I take this direction as my positive x direction. We know that the conservation of momentum equation is m1u1 plus m2u2 is equal to m1v1 plus m2v2. Okay, that means the momentum before the collision, the total momentum before the collision is equal to the total momentum after the collision. For that, we need to substitute these values. m1 is 2m into u1 is 3u plus m2 is 3m into u2 is u, but this u is in the opposite direction. This is my positive x direction, so I can substitute a negative value here, is equal to again m1 2m into v1 minus 3u by 2 plus m2 is 3m into v2. We don't know the value of v2, we need to find it out. Okay, so this is the equation. Now we can simplify this equation, that is 6mu then minus 3mu equals minus 3mu plus 3mv2. Now we can cancel these parts, minus 3mu minus 3mu, then the remaining 6mu equals 3mv2. So we can take v2 from here. v2 is equal to this m and this m, we can get we can cross it out. Then v2 is equal to 6 by 3 u, that is equal to 2u. So v2, this is first answer, v2 is equal to 2u. Our first question is find the speed of B immediately after the collision. So the speed of B immediately after the collision is 2u. Okay, now we can move to the second question. What is the second one? Find the magnitude of the impulse exerted on A by B in the collision. So we need to draw this figure again. So this is the figure. Particle A, particle B, initial velocity of A, initial velocity of B, final velocity of A, final velocity of B. Now the final velocity of B, we know that. What is the value of B? The final velocity of V, we already calculated, that is 2u. Okay, now we need to find out the impulse. So this I is the impulse on A and this I is the impulse on B, and these impulse should be same. The impulses are same. Okay. Now we can take any particle. We can take particle A or particle B to find out the impulse, because the impulse acting on the particle A and particle B are the same. So we can take any particle. So I am going to take the particle A. So I am going to take particle A. So impulse for A. So I can take this as my positive direction. Okay. So we know that the impulse momentum equation I is equal to m into v minus u. Okay. Or the impulse momentum principle is I is equal to mv minus mu. What is impulse momentum principle? That means impulse is equal to the change in momentum. Change in momentum is final momentum minus initial momentum. So here we take the particle A, so the mass is same, so I can take the mass outside. So the final equation is I is equal to m into v minus u. Okay. Now we can substitute the values. That is, m means the mass of particle A, that is 2m, into v is 3u by 2 minus u is 3u, but 3u is in the opposite direction, so I substitute a negative value. That is equal to, you can simplify 2m into 3u by 2, minus of minus is plus 3u. Now 2m into, you can take the common, this is 2 here, then 3u plus, then this 3u multiplied with 2, that is equal to 2m into 9u divided by 2, then this 2 get cancelled, then the remaining term is 9mu. This is the impulse. Okay. So our question is, find the magnitude of the impulse exerted on A by B in the collision. The value is 9mu. Okay.